In this lecture, I'm going to solve this question. In commuting to work, a professor must first get on a bus near her house and then transfer to a second bus. If the waiting time at each stop has a uniform distribution with A is equal to 0 and B equal to 5, then it can be shown that the total waiting time y has this probability density function. In the part A, we have to sketch a graph of the PDF of y. So let's take it step by step. In part A, we have to sketch a graph of the PDF of y, and we are given that this is the function. Okay, this is the probability density function. So first of all, let's use this probability density function to list the value of f of y for some of the values of y. So let's say that y takes these values 5, 6, 7, 8, 9 and 10. And now let's find the value of f of y for all these values of y. So when y is equal to 0, f of y is equal to 1 divided by 25y. So this is also equal to 0. When y is equal to 1, f of y is 1 by 25. So this is 0.04. When y is equal to 2, f of y is equal to 2 divided by 25. So this is 0.08. Similarly, we can use this probability density function to calculate the value of f of y for all these values of y. So let me write down what are the values that we will get. So these are the values that we will get for f of y for all these values of y. Now we have to just plot these values. So let's draw a horizontal axis and a vertical axis. So this is the vertical axis and this is the horizontal axis. Here we have f of y and here we have y. Y can take values starting from 0. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 here. And here we have 0.04, 0.08, 0.12, 0.16 and 0.20. So when we plot all these points on this graph, we will get something like this. So this is how it will look like. It is 0.20 here and the value 0.20 is when y is equal to 5. So this is how the density curve will look like in this case. So this is all about part A. This is the graph of the PDF of y. Let's now move to part B. In part B, we have to verify that the integral of f of y dy from minus infinity to infinity is equal to 1. So the integral of f of y dy from minus infinity to infinity can be written as 0, because for y less than 0, f of y is equal to 0, plus integral of 1 divided by 25y dy from 0 to 5, plus integral of 2 divided by 5 minus 1 divided by 25y from 5 to 10 dy plus 0. This 0 because f of y is equal to 0 for values of y greater than 10. So this is equal to 1 divided by 25 y square divided by 2. We have 0 here and 5 here, plus 2 divided by 5y minus 1 divided by 25 y square divided by 2, and we have 5 here and 10 here. So this is 5 actually, and this is also 5, plus 0. And solving this, we get 1 divided by 25, and here we have 25 divided by 2, plus 2 by 5 multiplied by 5 minus 1 minus 25, 100 divided by 2 minus 25 divided by 2. I have skipped one step here, but this is what you will get after solving it. And solving this, you get 1 upon 2 plus 2 minus 1 divided by 25 into 75 divided by 2. This is 3. So it is equal to 1 divided by 2 plus 2 minus 3 by 2. And this is equal to 1 plus 4 minus 3. And this is equal to 2 divided by 2, which is equal to 1. And this is what we wanted to show. So this is all about part B. Let's move to part C. In part C, we have to find what is the probability that total waiting time is at most 3 minutes. So that means we have to find the probability that y is less than equal to 3. This is equal to the integral of f of y dy from 0 to 3. Now for values of y between 0 and 3, we know that f of y is equal to 1 divided by 25y. So this is equal to integral of 1 divided by 25y dy from 0 to 3, and this is equal to 1 divided by 25y squared divided by 2, and we have 0 and 3 here, and this is equal to 1 divided by 25 multiplied by 9 divided by 2. Solving this, we get 9 divided by 50, and this is equal to 0.18. So this is all about part C. Let's now move to part D. In part D, we have to calculate the probability that total waiting time is at most 8 minutes. So that means we have to calculate the probability that y is less than equal to 8. So this is equal to integration of f of y dy from 0 to 8. Now the f of y is equal to 1 divided by 25y for the values of y between 0 and 5, and for the values of y between 5 and 8 it is equal to this. So let's write it as integral of 1 divided by 25y dy from 0 to 5 plus integral of 2 divided by 5 minus 1 divided by 25y from 5 to 8, and we have a dy here as well. This is equal to 1 divided by 25 y square divided by 2, and we have 0 and 5 here, plus 2 divided by 5y minus 1 divided by 25 y square divided by 2, and we have 5 and 8 here. Solving this, we get 1 divided by 25 multiplied by 25 divided by 2 plus 2 by 5 multiplied by 3 minus 1 by 25 multiplied by 64 by 2 minus 25 divided by 2, and this is equal to 1 divided by 2 plus 6 divided by 5 minus 1 divided by 50, and 64 minus 25 is 39, and solving this we get 1 divided by 2 plus 50 here, it's 60 minus 39, and this is equal to 1 divided by 2 plus 21 divided by 50, and this is equal to 0.5 plus 0.42, and 0.92 is the answer. Now let's move to part E of this question. In part E, we have to find the probability that total waiting time is between 3 minutes and 8 minutes. So that means we have to find the probability that y is greater than equal to 3 and less than equal to 8. This is equal to integrating f of y dy from 3 to 8, and we can write it as integral of 1 divided by 25y from 3 to 5 dy plus integral of 2 divided by 5 minus 1 divided by 25y dy from 5 to 8, and this is equal to 1 divided by 25 y square divided by 2, and we have 3 and 5 here, plus 2 divided by 5y minus 1 divided by 25 y square divided by 2, and we have 5 and 8 here. I'm sure you can solve it now, and solving this we will get 0.74. So this is the answer that we will get for part E. Let's move to part F. In part F, we have to find the probability that total waiting time is either less than 2 minutes or more than 6 minutes. So that means we have to find the probability that y is less than 2 or y is greater than 6. So this is equal to integrating 1 divided by 25y from 0 to 2 and a dy here, plus integrating 2 divided by 5 minus 1 divided by 25y from 6 to 10, and plus 0 because for y greater than 10 f of y is equal to 0, and this is equal to 1 divided by 25 y square by 2, and we have 0 and 2 here, plus 2 divided by 5y minus y square divided by 50, because y square divided by 25 multiplied by 2, and we have 6 and 10 here. So we can solve this, and after solving this you will get 0.4, which is the answer to this part. So with this we are done with this question.